Hi everyone, and welcome to this audiobook designed for the EWRB Electrician Regulation Exam. My name is Aria, and I work alongside Whit Roy as an electrical tutor. This audiobook explains the exam topics in simple spoken language, making it easier to understand and review anywhere, anytime. Before we get into the lesson, I want to explain what this audiobook actually is. This audiobook is not a word-for-word reading of ASNZS 3000. You must always refer to the real standard when you're doing electrical work or preparing for an assessment. What we do here is take the important ideas from the standard and rewrite them in simple spoken English. The goal is to make the rules easier to understand, easier to remember, and easier to revise, especially when you're listening on the go. So think of this audiobook as a learning guide, not a replacement for the actual standard. Alright, let's begin. Today we're going into Section 7, Special Electrical Installations, which looks at special electrical installations. These are the kinds of installations that need extra care because the conditions are different from normal work, or the risks are higher than usual. As we move through this section, we'll look at the rules that apply to safety services, to generation systems, to isolated supplies, to extra low voltage work, to high voltage systems, and to hazardous areas. Everything in this section has one purpose, and that's to make sure the installation stays safe when the environment or the equipment adds extra risk. Let's go through each clause step by step and explain what the standard is asking for. Clause 7.1 General. Clause 7.1.1 Application. This clause explains that the rules in Section 7 set the minimum standard for choosing and installing electrical equipment in special electrical installations. These minimum rules must still meet the safety outcomes required in Part 1 of this standard. Clause 7.1.2 Selection and Installation. This clause explains that each type of special installation has requirements that either change or replace the usual rules found in other sections of the standard. When Section 7 does not give a specific rule, the relevant rules from the other sections must be followed. The clause also states that Section 7 applies to electrical systems used for safety services, electricity generation systems, and installations using electrical separation. It applies to extra low voltage installations, high voltage installations, and installations in areas where an explosive hazard could occur. It also applies to electrical installations on construction and demolition sites, electromedical treatment areas, and relocatable installations and the sites they supply. It includes marinas and recreational boats, shows and carnivals, and cold cathode illumination systems. It applies to telecommunication network power supplies, cranes and hoists, lifts, generating sets, and outdoor sites exposed to heavy conditions. It also includes electric fences, and film, video, and television sites. Clause 7.2 Safety Services. Clause 7.2.1 Scope. Clause 7.2.1.1 General. This clause explains that the special requirements in Clause 7.2 apply to electrical work for building services that must keep running for safety reasons. These include systems for fire detection, warning systems, extinguishing systems, smoke control systems, evacuation systems, and systems that protect people during emergencies. The purpose is to make sure the electricity supply is not accidentally disconnected from equipment that must work during an emergency. The notes explain that ASNZS 3009 provides guidance for emergency power in hospitals, and that the term safety services covers equipment described as emergency systems in the older standard, and equipment called emergency or essential service under the building code. Clause 7.2.1.2 Fire and smoke control equipment. This clause explains what is included as fire and smoke control equipment for the purposes of this section. It includes fire hydrant booster pumps, pumps for automatic sprinkler systems, water spray or deluge systems and similar extinguishing systems, and pumps for fire hose reels when these reels are the only firefighting equipment in the area. It also includes fire detection and alarm systems, and air handling systems designed to exhaust and control the spread of fire and smoke. The clause states that the requirements do not need to apply to electrical equipment where its failure does not affect safety services, and examples include pumps used only for jacking or water pressure maintenance when this does not affect the hydrant pump that provides water supply, and pumps for fire hose reels when the reels are not the only extinguishing system, such as where sprinklers are installed. It also includes smoke alarms installed in single private residences, and the note draws attention to the standards applying to fire pumps, automatic sprinkler systems, fire detection and alarm and intercom systems, and air handling systems. The clause also notes that although the listed standards are referred to, compliance with this standard may still require meeting other regulatory requirements. Clause 7.2.1.3 Evacuation Equipment. This clause explains that evacuation equipment includes sound systems and intercom systems used for emergencies, and central system emergency evacuation lighting that complies with the ASNZS 2293 series. The note points to requirements for sound systems and intercoms in the AS1670 series, and for emergency evacuation lighting in the ASNZS 2293 series. It also notes that although those standards are listed, there may be extra requirements from regulatory authorities. Clause 7.2.1.4 Lifts. For this clause, lifts are considered safety services when they are electrically controlled lifts used to carry people, but not lifts where people can safely exit at any point in the travel, such as escalators. The clause lists two exceptions. The first is that a lift that allows passengers to get out safely when electricity fails does not need to be arranged as a safety service. The second is that a lift in a single private residence that meets as NZS 1735.18 need not follow Clause 7.2. The note explains that although the AS 1735 series is mentioned, compliance with it may require additional regulatory requirements. Clause 7.2.2 Supply Systems. Clause 7.2.2.1 Separation of supplies. This clause explains that the electrical parts supplying a safety service must be controlled by a main switch or switches that are separate from those used for the rest of the electrical installation, as described in Clause 7.2.3 and Clause 7.2.4. Circuits supplying safety services must also be separate from circuits supplying the rest of the installation. An electrical source used for safety services may also be used for other purposes as long as the availability of safety services is not reduced. The note explains that when safety services are needed, it might be necessary to disconnect power to other equipment. Clause 7.2.2.2 Discrimination of circuit protective devices. This clause explains that protective devices must be chosen so a fault on one safety service does not cause loss of supply to another safety service, and a fault on the general installation does not cause loss of supply to safety services. Fault current limiters used for safety services must not be used to protect any part of the general installation. The note explains that this discrimination applies only up to the level of arcing fault current stated. Clause 7.2.2.3 Alternative Supply Systems. This clause explains that when an alternative supply is provided, a changeover switch must be installed at the main switchboard so the alternative supply can feed the safety services. The generating set or other supply must be able to operate all safety services at the same time, including the initial current needed for startup or motor starting. An alternative supply of adequate size may also start working automatically if the normal supply fails. The clause then lists three exceptions. The first is that a changeover switch for fire or smoke control equipment or evacuation equipment may be located on a dedicated switchboard or control panel. The second is that a changeover switch for smoke control or evacuation equipment may be on or beside the equipment being controlled. The third is that a changeover switch for a lift may be in the lift motor room. The notes explain that alternative supply systems for hydrant and sprinkler pumps are restricted by the relevant standards, and that ASNZS 3010 provides guidance on generator connections. Clause 7.2.3 Main switches. Clause 7.2.3.1 General. This clause explains that any part of an installation supplying a safety service must be controlled by a main switch that is separate from the switches used to control the rest of the installation and other safety services. The clause then lists two exceptions. The first relates to lighting equipment and a socket outlet used for a fire pump circuit in line with Clause 7.2.4.3. The second allows submains feeding an outbuilding or separate part of an installation to be controlled by switches in line with Clause 7.2.3.3 and Clause 7.2.6. Clause 7.2.3.2, Number of main switches. This clause explains that there is no limit on the number of main switches provided for safety services. Clause 7.2.3.3, Outbuildings and fire-separated portions of a building. This clause explains that a switch used for controlling safety services installed in an outbuilding and located on that outbuilding's switchboard is treated as a main switch and must follow Clause 7.2.3.1. Parts of a structure with walls providing at least 120 minutes fire resistance may be treated as separate buildings for this clause. Any switch for safety services in such a separate building must be separate from switches used to control the rest of the installation and other safety services. The clause lists an exception for lighting equipment and a socket outlet used for a fire pump circuit in line with Clause 7.2.4.3. Clause 7.2.3.4, Special lifts. This clause states that each lift or group of lifts that must operate for firefighting or for other emergency purposes must be controlled and protected independently of all other lifts. Clause 7.2.4, Arrangement. Clause 7.2.4.1, Supply. This clause explains that main switches for safety services must be connected on the supply side of all general installation main switches, must not be controlled by them, and must control only equipment regarded as safety services. The note refers to a figure for guidance. The clause lists exceptions. The first is a high-voltage switch that supplies a low-voltage switchboard not regarded as a general installation main switch. The second is a low-voltage switch that can only be used by authorized people and is clearly marked. The note explains that locking a switch may be a way to ensure only authorized people can use it. The third exception relates to automatic fire detection, alarm, intercom, and sound systems for emergencies that are supplied from the supply side of a distribution board not more than one board away from the main switchboard, and are marked in line with Clause 7.2.6. and are provided with a secondary power source in line with the AS1670 series or NZS 4512. The fourth exception is safety services in an outbuilding in line with Clause 7.2.3.3. The fifth is a switching arrangement that keeps a secure supply. The sixth is an alternative supply provided in line with Clause 7.2.2.3. Clause 7.2.4.2, Interposing switches. This clause explains that no switch may be placed between a main switch for safety services and the switchboard supplying safety services. The clause lists two exceptions. The first is where an alternative supply is provided in line with Clause 7.2.2.3. The second is where the switches are remote from the building being supplied, such as upstream switches feeding an outbuilding. Clause 7.2.4.3, Pump rooms. This clause explains that in rooms used mainly for hydrant or sprinkler pumps, lighting equipment and socket outlets may be connected as a final subcircuit to the circuit supplying the pump equipment if certain conditions are met. The final subcircuit must be protected against overcurrent in line with Clause 2.5, must be protected by an RCD with a rating not more than 30 mA, and the wiring system between the pump equipment circuit and the protective device must meet the current carrying and installation requirements of Clause 2.5.3.1, and must meet the type and segregation requirements of Clause 7.2.7.2 and Clause 7.2.8. The note explains that the wiring system between the protective device and the lighting equipment does not need to meet the type requirements of Clause 7.2.7.2. Clause 7.2.5. Mechanical protection. This clause explains that switches and control equipment that are part of a safety service installation must be properly protected if they may be exposed to damage because of where they are located or how they are used. Clause 7.2.6, Identification. Clause 7.2.6.1, General. This clause explains that all switches in the supply circuit for safety services must be clearly identified so people can tell which safety service they control. Clause 7.2.6.2, Main switches. This clause explains that main switches controlling safety services must be identified to show which safety service they operate, must be marked with the words "in the event of fire, do not switch off," and must be identified by contrasting colors or another suitable method in line with Clause 2.3.3.4. Clause 7.2.6.3, Electrical installations in outbuildings. This clause explains that a safety service main switch installed in an outbuilding must be clearly identified in line with Clause 7.2.6.1 and Clause 7.2.6.2. The note explains that a switch for safety services on the switchboard of an outbuilding is treated as a main switch in line with Clause 7.2.3.3 subclause A. Clause 7.2.6.4, Special lifts. This clause explains that main switches controlling lifts arranged under Clause 7.2.3.4 must be identified in line with Clause 7.2.6.1 and 7.2.6.2, and must also be identified separately from the main switches for other lifts. Clause 7.2.6.5, Identification of alternative supply system. This clause explains that when an alternative supply system may be affected by the operation of a switch, extra marking is required in line with Clause 2.3.3.4 and Clause 7.3.8.1.2 subclause A. Clause 7.2.7, Wiring systems. Clause 7.2.7.1, General. This clause explains that wiring systems supplying safety services must be able to keep supplying the equipment when exposed to fire. Clause 7.2.7.2, Type of wiring. This clause explains that wiring systems supplying safety services, including consumers' mains, must comply with ASNZS 3013 with AWS classification or the classification given in the standard applying to the installation. The note refers to Appendix H for more detail on the WS system. The clause also explains that when a standard does not specify a WS classification, the wiring system must be one that can keep supplying the equipment when exposed to fire or when exposed to mechanical damage, or when protected from these hazards by suitable enclosure or by installation in a place where the wiring is not likely to be damaged. The clause includes an exception stating that the fire and mechanical protection requirements do not need to apply when wiring systems are in an enclosure or location that gives the required protection, such as underground cable ducts, concrete or masonry walls or floors, or other fire-rated enclosures with suitable mechanical protection. Clause 7.2.7.3, Wiring for safety services. This clause explains when wiring for safety services must be separate from other wiring. It lists several situations in which wiring may be combined with other circuits. These include fire detection and alarm circuits compliant with AS1670 or NZS 4512 beyond the control and indicating panel, circuits that provide the primary power source for fire detection and alarm systems that have battery backup in line with AS1670 or NZS 4512 up to the control and indicating panel, circuits for fire detection for fire and smoke control equipment compliant with its NZS 1668.1, circuits for lighting and socket outlets in pump rooms installed in line with Clause 7.2.4.3, circuits for emergency warning systems that have battery backup and comply with AS1670 or NZS 4512 up to the main panel, circuits for emergency warning systems that comply with AS1670 or NZS 4512 beyond the main equipment panel, circuits supplying lifts beyond the terminals of a circuit breaker in the lift machine room for control and protection of the lift installation, circuits for electric-driven fire pumps that are part of a pump set including a standby fuel-driven pump, and circuits supplying battery chargers for battery-operated single-point lighting systems used for emergency evacuation. Clause 7.2.8, Segregation. Clause 7.2.8.1, Switchgear. This clause explains that when emergency equipment is required by national building codes, switchboards supplying that equipment must be constructed so the emergency equipment switchgear is kept separate from other switchgear by metal partitions to reduce the spread of faults. Clause 7.2.8.2, Cables in the same enclosure. This clause explains that conductors of safety services must not share the same enclosure with conductors of other systems. It explains that for this clause, A duct or trunking divided into separate channels by fixed continuous barriers may be treated as separate enclosures. It also states that wiring systems compliant with Clause 7.2.7.2 may be considered to give effective segregation. It also explains that wiring systems within switchboards must be separated from other wiring by at least 50 mm or by suitable barriers. Clause 7.2.8.3 Conductors and multi-core cables. This clause explains that conductors for different safety services must not be included with each other or with other conductors of any other system within a multi-core cable. Clause 7.2.9 Fire pump motors. Clause 7.2.9.1 Isolating switches. This clause explains that when fire pump motors are controlled automatically, a manually operated isolating switch must be installed on the supply side of the pump motor controller. The isolating switch must meet the requirements of Clause 2.3.3.2, must be installed either next to or on the pump motor controller, and must have a device that allows the switch to be locked in the closed position. Clause 7.2.9.2 Overcurrent protection. This clause explains that the overcurrent protective devices for fire pump motors must have an inverse time characteristic and must be rated or set so they can carry 125% of the full load motor current continuously, and can open the circuit in not less than 20 seconds at 600% of that current. It also explains that no other overcurrent protective device may be placed between the pump motor controller and the motor. When more than one motor is on the same circuit, the protective device must carry 125% of the total full load current of all motors running together, and must open the circuit in not less than 20 seconds at 600% of the full load current of the largest motor connected. Clause 7.2.9.3 Overtemperature protection. This clause explains that overtemperature protection must not be used on fire pump motors when such protection might reduce the ability of the equipment to operate during an emergency. Clause 7.2.9.4 Control circuits. This clause explains that control circuits for fire pump motors must be directly connected between the active and neutral conductors of the pump circuit. The note explains that this requirement prevents the use of transformers. Subclause B explains that the active conductor of the control circuit must be directly connected to the coil of the operating device inside the starter. Subclause C explains that overload protective devices must not be installed on the control circuit other than the devices already required for the pump motor circuit in line with Clause 7.2.9.2. The note explains that this arrangement requires a switch in the neutral conductor of the control circuit for a fire pump. Clause 7.3 Electricity generation systems. Clause 7.3.1 General. This clause explains that the requirements in this part add to, or modify, the rules in sections 2 to 7 for electricity generation systems that supply electrical installations either all the time or only sometimes. It lists the types of generation systems that may be used. The first is an engine-driven generator set, which typically uses a combustion engine. It can provide standby or alternative supply when the main power fails, act as the main supply to an installation, or be used in a standalone system. The second is a standalone power system that connects a renewable energy source such as solar, wind, or mini hydro to an installation, and can provide an AC supply from an inverter, or a DC supply. The note explains that such a system may also include an engine-driven generator. The third type is a grid-connected inverter system that provides AC power from an interactive inverter using renewable sources such as solar, wind, or mini hydro. The notes explain that grid-connected means the installation can run in parallel with the distribution system, and that these systems may include an engine-driven generator. Another note explains that the connection of a grid-connected inverter system needs formal agreement with the electricity distributor. The clause also explains that when renewable energy output is higher than the installation load, and approval is given by the distributor, the excess energy may be exported to the distribution system. When renewable energy output is too low for the installation load, the shortfall must be imported from the network. The interactive inverter also controls the importing and exporting of energy. The clause also includes a battery system that provides supply from a renewable source to charge a battery bank and provide a DC supply to an installation. Clause 7.3.2 Selection and installation of system. This clause explains that the equipment chosen, installed and controlled as part of an electricity generation system must follow the relevant standards. These include ASNZS 3010 for engine-driven generating sets, AS4509 for standalone power systems, AS3011 for battery systems, ASNZS 5033 for photovoltaic systems, and AS4777 for grid-connected inverter systems. Clause 7.3.3 Control. This clause explains that an electricity generation system must be controlled by an isolating switch or switches at the source of supply or at the switchboard where the system connects into the installation. The system must also be controlled by switches or devices suitable for starting and stopping it, and when more than one device is used they must be grouped together and clearly identified. The system must be arranged so that it cannot supply energy upstream of the connection point either directly or indirectly. The clause includes an exception that an electricity distributor may enter into an agreement for cogeneration or exporting energy into the upstream network under certain conditions. The note explains that the connection rules for grid-connected systems, cogeneration and other similar systems operating in parallel with the distributor's network are outside the scope of this standard. Clause 7.3.4 Isolation. Clause 7.3.4.1 General. This clause explains that each electricity generation system must have an isolating switch in line with Clause 2.3.3.2. The switch must be installed next to, or on, the system so the operator can clearly see any person working on it, or must include a means that requires a deliberate action to operate. It may be combined with overcurrent protection required by Clause 7.3.5.1. It must comply with Clause 4.13 when the system includes an electric motor, and must be under manual control only. It must not be able to be overridden or bypassed by programmable controls. The clause includes an exception stating that isolation arrangements in AS4509 or the AS4777 series are accepted as meeting these requirements. Clause 7.3.4.2 Electricity generation systems incorporating batteries. This clause explains that when batteries are included in the system, a switch capable of interrupting the supply from the batteries must be installed next to the isolating switch and clearly labeled. The clause includes an exception allowing a single switch that incorporates both AC and DC switching functions described earlier. Clause 7.3.5 Overcurrent protection. Clause 7.3.5.1 Electricity generation systems. This clause explains that electricity generation systems must have overcurrent protection. The clause includes an exception stating that overcurrent protection must not be provided where the sudden loss of supply could cause greater danger than leaving the system running. Overcurrent protective devices must be located as close as practicable to the open terminals of the system so the unprotected cable length within the installation is as short as possible and never more than 15 meters. Clause 7.3.5.2 Circuit protection. Clause 7.3.5.2.1 General. This clause explains that the prospective short circuit and earth fault current must be assessed for each electricity generation system or combination of systems capable of supplying the installation. The short circuit rating of protective devices must not exceed the rating of any part of the intended path of electricity generation. The note explains that if the system has an electronic overcurrent protection device such as an inverter that automatically limits output during faults, it may prevent the external overcurrent device from disconnecting the installation under fault conditions. The clause states that every circuit leaving the generation system must be protected in line with Clause 2.5 and include additional earth leakage protection if required by Clause 2.6. A circuit is considered protected against prospective short circuit and earth fault currents when it is supplied by a system incapable of delivering a current exceeding the rating of the circuit. The note explains that supply sources like small generators or inverters may limit fault current. The clause includes an exception stating that overcurrent protection must not be provided where sudden loss of supply could cause greater danger than leaving the system energized. Clause 7.3.5.2.2, ASNZS. This clause explains that the fault current waveform can affect how ASNZS operate and must be considered when choosing them. When the system includes an inverter, the RCD must be suitable for the inverter's waveform in line with the manufacturer's instructions. The note explains that RCD types are covered in Clause 2.6.2.2. Clause 7.3.6, Earthing. This clause explains that the earthing system of the installation must follow Section 5 as an MEN system. An exception states that when the system output does not exceed 25 kV, the output may be arranged as a separated supply in line with Clause 7.4. Any exposed conductive parts of the system must be earthed to the main earthing conductor at the main switchboard. When several independent generation systems with engine-driven generators operate in parallel, the neutral connection of each generator winding must be switched so that only one neutral is connected to earth at one time. The note explains that this rule prevents circulating currents between generators. Clause 7.3.7, Connected electrical equipment. This clause explains that any accessory, conductor, insulation or other component connected to the output of an electricity generation system must be suitable for the voltage, current and frequency of the output unit. The note explains that current carrying capacity and voltage drop for conductors must follow ASNZS 3008.1 for 50 Hz systems. Clause 7.3.8, Connection to electrical installation. Clause 7.3.8.1, Alternative supplies. This clause explains that the following rules apply when connecting an alternative or standby supply to an installation. Clause 7.3.8.1.1, General. Subclause explains that the neutral to earth connection, called the MEN connection, must be made within the installation at the switchboard where the electricity generation system connects. The note explains that this may require disconnecting any neutral to earth connection within the generating system itself, such as an engine-driven generator set. Subclause B explains that the incoming neutral to an MEN switchboard must not be switched. The note explains that this applies to any switchboard that has an MEN connection and may be a main switchboard or a switchboard in an outbuilding treated as a main switchboard for earthing. Subclause C explains that the neutral and earth conductors must not operate in parallel. An exception explains that when connected to a distribution switchboard and operating on the alternative supply, the submain neutral and protective earthing conductors may operate in parallel through a remote MEN connection if the conductors are not overloaded by current sharing, the conductors are suitable for the maximum fault current, the copper earthing conductors meet the requirements of Clause 5.3.3, and the current carrying capacity of the neutral conductors is not less than their associated active conductor. Clause 7.3.8.1.2, Switching. This clause explains that the changeover device for an alternative supply must be chosen so that it maintains the function of the installation and prevents damage to the installation being supplied. The note explains that examples include maintaining the continuity of the neutral conductor, the operation of RCDs, and the continued operation of uninterruptible power supplies. The clause explains that the changeover device must open all active conductors of the normal supply when the alternative supply is connected. It explains that where a switch automatically brings the alternative supply into service, the purpose of that switch must be marked. It also explains that switching arrangements in line with ASNZS 3010 are considered to meet these requirements. The note explains that typical switching arrangements are shown in Figures 7.2, 7.3, and 7.4. Clause 7.3.8.2, Grid-connected inverter systems. Clause 7.3.8.2.1, General. This clause explains that connecting a grid-connected system requires a formal agreement with the electricity distributor. Clause 7.3.8.2.2, Switching. This clause explains that a main switch must be provided to isolate the inverter output from the switchboard it is connected to. All switches must be clearly identified for their function in line with Clause 2.3.2. Clause 7.3.8.2.3 Connection. This clause explains that the method of connection for a grid-connected inverter system must follow the AS4777 series as well as the distributor's requirements. The system must not impose a voltage on the installation at the network point of supply outside the limits in Clause 1.6.2.c. The note explains that a typical interactive inverter AC connection and main switch is shown in Figure 7.5. Clause 7.3.8.3 Standalone power systems. Clause 7.3.8.3.1 General. This clause explains that the consumer's mains of the installation must be connected to the output of the electricity generating system. Clause 7.3.8.3.2 Switching. This clause explains that control of the installation must be arranged in line with Clause 2.3. Clause 7.3.8.3.3 Connection. This clause explains that the connection method of a standalone system must follow the ASNZS 4509 series. The note explains that a typical standalone connection is shown in Figure 7.6, using a switchboard that includes a local MEM connection. Clause 7.4 Electrical separation, isolated supply. Clause 7.4.1 Scope. This clause explains that several methods of protection against indirect electric shock are recognized in Clause 1.5.5. One method is protection by electrical separation of the supply. Electrical separation is an alternative method to prevent shock current through exposed conductive parts that may be energized by a fault in the insulation of a circuit. Protection by electrical separation must follow Clauses 7.4.2 to 7.4.4. and either Clause 7.4.5 for a single item of equipment or Clause 7.4.6 for more than one item. The note explains that Figure 7.7 shows examples of separated supply. Clause 7.4.2 Source of supply. This clause explains that the supply for a separated circuit must be from an isolating transformer that complies with ASNZS 61558. Or from a generator output that is isolated so the output is separated from the frame of the generator. The note explains that using an RCD or equipping a generator with an equipotential bonding conductor does not provide the correct separated output. The clause also allows an isolated inverter that complies with the safety requirements of ASNZS 4763 International. Clause 7.4.3 Arrangement of circuits. This clause explains that a separated circuit must not exceed 500 volts. All parts of a separated circuit must be reliably and effectively separated from all other circuits. Notes explain that this can be achieved by using Class II insulation or similar methods, and that this rule applies to relays, contactors and similar equipment. Each separated circuit must use a separate cable or wiring system, although multi-core cables, or a common non-conductive wiring enclosure may be used where the segregation requirements of Clause 3.9.8 are met. Exposed conductive parts supplied by the separated circuit must not be connected to any protective earthing conductor or exposed conductive parts of the source of supply. Cables and flexible cords for equipment must be protected from damage or arranged to ensure any damage can be seen. Clause 7.4.4 Switching devices. This clause explains that switching devices must operate in all live conductors of a separated circuit. The note explains that switching the active conductors of an isolating transformer in line with Clause 2.3.2 is acceptable for isolating and reconnecting supply. Clause 7.4.5 Single item of electrical equipment. This clause explains that when a separated circuit supplies a single item, no exposed conductive parts of that item may be connected to exposed conductive parts of any other circuit. Exposed conductive parts must not be connected to earth. Clause 7.4.6 Multiple items of electrical equipment. This clause explains several requirements when a separated circuit supplies more than one item. Exposed conductive parts must be connected together by an insulated equipotential bonding conductor and must not be connected to earth, to protective earthing conductors, or to exposed conductive parts of another circuit. Any socket outlet installed on the separated circuit must have its designated earthing contact connected to the equipotential bonding conductor. The designated protective earthing conductor of any supply cable or flexible cord to the equipment must be connected to the equipotential bonding conductor. Exposed conductive parts of the source of supply that are earthed must not be accessible at the same time as exposed conductive parts of the separated circuit. A protective device must disconnect the separated circuit automatically if faults expose conductive parts to different potentials. If the device is a circuit breaker, it must open all unearthed conductors at the same time. Clause 7.4.7 Testing. Clause 7.4.7.1 General. This clause explains that separated circuits must be tested in addition to the testing in Section 8. The separation must be verified by measuring the insulation resistance between the separated circuit and the transformer primary, any other wiring, and earth. Insulation resistance must be at least 1 megohm when tested at 500 volts DC. The note explains that shorter circuits may have much higher insulation values. Clause 7.4.7.2 Single items of electrical equipment. This clause explains that for a single item supplied by a separated circuit, separation must be verified as required earlier and by measuring resistance between exposed conductive parts and the earth contact of a socket outlet. Clause 7.4.7.3 Multiple items of electrical equipment. This clause explains that for more than one item on a separated circuit, separation must be verified as required earlier and by measuring resistance between the separated circuit and its equipotential bonding conductor, between the bonding conductor and earth, and between the bonding conductor and any equipotential bonding conductor of another separated circuit. Clause 7.4.7.4 Bonding conductor continuity. This clause explains that the resistance of the equipotential bonding conductor for socket outlet earth contacts or exposed conductive parts connected to the separated circuit must not be more than 0.5 ohms. Clause 7.5 Extra low voltage electrical installations. Clause 7.5.1 Scope. This clause explains that it applies to parts of an electrical installation operating at extra low voltage and sets the requirements for meeting Clause 1.5.7 of the standard for both basic protection and fault protection when extra low voltage is used. Clause 7.5.2 Compliance with other sections. This clause explains that extra low voltage installations must be of either SELV or PELV systems. The particular requirements in this clause replace or modify other parts of the standard when needed. If no special requirement is given in this clause, the installation must follow the other sections. When an installation operates at extra low voltage but does not meet the rules for SELV or PELV, it is considered to be an installation operating at low voltage and must meet the requirements for low voltage systems. Clause 7.5.3 Sources of supply by SELV and PELV. This clause explains that the supply for a SELV or PELV system must be from one of several sources. These include a safety isolating transformer that complies with ASNZS 61558, or a source of current independent of higher voltage systems such as an engine-driven generator or a battery, or a source of current separate from higher voltage systems such as a motor generator set with separate windings that provide electrical separation. The clause also allows certain electronic devices that limit the output voltage to extra low values under both normal and fault conditions. The note explains that such devices include insulation testing equipment. Clause 7.5.4 Separation requirements for SELV and PELV circuits. This clause explains that live parts of SELV and PELV circuits must be electrically separated from each other and from higher voltage circuits. Arrangements must provide a level of separation equal to that between the input and output of a safety isolating transformer that complies with ASNZS 61558. SELV and PELV conductors must be segregated from other circuit conductors. An exception explains that SELV and PELV circuits installed in line with Clause 3.9.8.3 may be within the same wiring system as low-voltage circuits. Live parts must be arranged so that short-circuiting or bridging between live parts or between live parts and conductive materials cannot occur under normal expected conditions. Clause 7.5.5 Arrangement of SELV circuits. This clause explains that live parts of SELV circuits must not be connected to earth or to protective earthing conductors or to live parts of other circuits. SELV circuits must not be connected to other circuits or to earthing conductors or exposed conductive parts of other systems or to extraneous conductive parts. An exception allows connection to extraneous conductive parts when equipment is designed to be connected in that way and the parts cannot reach a voltage greater than that of the SELV circuit. A note explains that if SELV circuits may come into contact with other exposed parts, the protective measure must be applied to those exposed parts and not to the SELV conductors. The clause also explains that when nominal voltage is above 25 volts AC or 60 volts ripple-free DC, basic protection against electric shock must be provided either by enclosures giving at least IP2X protection or insulation that withstands a 500 volt AC test for 1 minute. Notes explain that basic protection is not required when the voltage is below these limits, and that the insulation must withstand the test for the specified time. Clause 7.5.6 Arrangement of PELV circuits. This clause explains the requirements for PELV circuits where one conductor is earth. Basic protection must be provided by enclosures or barriers giving at least IP2X protection, or insulation that withstands a 500 volt AC test for 1 minute. An exception explains that basic protection may not be required when equipment is within the zone of equipotential bonding and the voltage does not exceed 25 volts AC or 60 volts ripple-free DC for equipment normally used in dry contact areas, or 6 volts AC or 15 volts ripple-free DC in other cases. Notes explain that earthing may be achieved by suitable connection, that ASNZS 60479 describes the surface area for large contact, and that the insulation must withstand the test voltage for the required time. Clause 7.5.7 Voltage drop in conductors. This clause explains that voltage drop at any point in an extra low voltage circuit must not exceed 10% of the nominal voltage when all live conductors carry the circuit's current. A note explains that more information is given in ASNZS 3008.1. An exception explains that this rule does not apply when equipment is designed for operation with a voltage drop greater than 10%. A second note explains that some equipment, such as motors, solenoids and items that draw high transient currents, may be affected by voltage drop and are excluded from this consideration. Clause 7.5.8 Control of an electrical installation. Clause 7.5.8.1 Main switches. This clause explains that the supply to an extra low voltage installation must be controlled by a main switch or switches operating in all unearthed conductors. An exception explains that this requirement does not apply when the extra low voltage installation is supplied from part of a higher voltage installation where the extra low voltage depends on the higher voltage supply and the high voltage main switch disconnects both systems. Clause 7.5.8.2 Other switches. This clause explains that switches must operate in all unearthed conductors when the supply is earthed at the point of supply, such as PELV switches may operate in one fewer conductor than the number of conductors in the circuit for SELV. Clause 7.5.9 Overcurrent protection. Clause 7.5.9.1 General. This clause explains that every extra low voltage circuit must have protection at its origin against overload and short-circuit currents as required in clauses 2.2 and 2.5. Protection may be provided in fewer conductors than the number of conductors in the circuit. When the supply is earthed, protective devices must be in all unearthed conductors. An exception explains that circuits in line with clause 7.5.9.2 do not need overcurrent protection. Clause 7.5.9.2 Emission of overcurrent protection. This clause explains that overcurrent protection does not need to be provided when interrupting the supply could cause greater danger than not interrupting, or when the rated output of the supply does not exceed the rating of the circuit, or when the circuit is supplied from a transformer that is short-circuit proof under ASNZS 61558 and the transformer output does not exceed 1 ampere or the short-circuit current is not more than the rating of the conductors and that value is marked on the transformer. It may also be emitted when the circuit is supplied from a battery with high internal resistance such as Leclanche type or dry primary cells. Clause 7.5.10 Connecting devices. This clause explains that plugs and socket outlets for SELV and PELV systems must meet certain requirements. Plugs must not be able to enter socket outlets of other voltage systems. Sockets must not accept plugs of other voltage systems. Sockets must not have a contact for an earthing conductor. Clause 7.5.11 Wiring systems. Clause 7.5.11.1 General. This clause explains that conductors and cable insulation used for extra low voltage installations must be suitable for their intended purpose and do not need further protection unless the conditions of use demand it. The note explains that segregation requirements and wiring system protection under Clause 3.9.8.3 may still apply. Clause 7.5.11.2 Aerial conductors. This clause explains that aerial conductors used in extra low voltage installations must follow Clause 3.12. Exceptions explain that clearances above ground or elevated areas do not apply when Clause 3.3.1 is met, and bare conductors may be used if they comply with the rules for insulated conductors. Clause 7.5.11.3 Underground conductors. This clause explains that there are no burial depth requirements for safety of extra low voltage cables. A note explains that possible mechanical damage must still be considered. Clause 7.5.12 Testing. Clause 7.5.12.1 General. This clause explains that extra low voltage circuits must be tested to confirm separation. Testing follows Clause 7.5.12.2 for SELV and Clause 7.5.12.3 for PELV. Insulation resistance measured under these clauses must not be less than 0.5 megohms when tested at 250 volts DC. Clause 7.5.12.2 Protection by SELV. This clause explains that separation of live parts from other circuits and earth must be confirmed by measuring insulation resistance. Clause 7.5.12.3 Protection by PELV. This clause explains that separation of live parts from other circuits must be confirmed by measuring insulation resistance. Clause 7.6 High voltage electrical installations. This clause applies to any part of an electrical installation that operates at high voltage. For protection and earthing purposes, the rules here also cover the equipment up to and including any low voltage cables and switchgear connected to high voltage transformers. This clause does not apply to electric discharge lighting systems, to X-ray equipment, to high-frequency equipment, or to any high-voltage wiring that is completely enclosed within self-contained equipment and supplied at low voltage where precautions stop contact with high-voltage parts. Clause 7.6.2.2 in New Zealand. In New Zealand, any electrical installation that operates at high voltage must be installed in line with the requirements of the New Zealand electrical regulations. Clause 7.6.3 Issues relevant to high voltage installations. When planning or designing high voltage electrical installations, a range of issues must be considered because the risks are more significant than for installations below 1 kV. These issues include ensuring the insulation can withstand the highest voltage and impulse levels, providing adequate clearances to live parts, and considering any special conditions that may reduce safe clearances. The way connected devices behave under high voltage must also be taken into account. The methods used to install equipment, cables and accessories are important, as are general installation requirements such as circuit arrangement, documentation, transport routing, lighting, operational safety and labeling. Special building requirements may apply, and careful thought must be given to safe access and protection against both shock and fire. The earthing system must operate correctly under all expected conditions, and there must be provision for testing. Clause 7.7 Hazardous areas, explosive gas or combustible dusts. Clause 7.7.1 Scope. This clause applies to the selection of electrical equipment and the way it is installed in areas where flammable or combustible materials are produced, prepared, processed, handled or stored. These situations may create an explosive atmosphere, and electrical equipment must be suitable for these conditions. Clause 7.7.2 Classification of hazardous areas. Responsibility for determining whether an area is hazardous rests with the people in control of the installation. Hazardous areas are defined using the requirements of ASNZS 60079.10.1 for gas or vapor, and ASNZS 60079.10.2 for combustible dust. Clause 7.7.2.2 Recognized hazardous areas. Two main types of hazardous areas are recognized. The first is hazardous areas formed by gas or vapor where a flammable atmosphere is present or may be present. These areas are divided into zones based on how often and how long the flammable atmosphere is expected, and include vapors arising from liquids. The second type is hazardous areas formed by dust. These areas involve clouds of combustible dust that may be present or may form, and special precautions are needed for installation and use of equipment. Dust hazards are also divided into zones, and the possibility of an explosive dust cloud forming above a settled layer must be considered. Combustible dust can include fibers and flyings. Clause 7.7.3 Reduction or elimination of the hazard. Through careful design, the level of hazard can often be reduced. This can include the way plant is laid out, the ventilation provided, and the selection of suitable equipment. Clause 7.7.4 Electrical equipment. Electrical equipment used in hazardous areas must meet the requirements of ASNZS 60079.14 for its selection and use. Clause 7.7.4.2 Installation. Electrical equipment must be installed following the requirements of ASNZS 60079.14. Additional requirements for competence of persons and inspection and maintenance are given in the associated standards. Clause 7.8 Specific electrical installation standards. Clause 7.8.1 Scope. This clause identifies standards that apply to particular electrical installations. Some give extra requirements to this standard, some provide requirements that, when met, are taken as complying with this standard, and others give guidance for special electrical installations. Clause 7.8.2 Additional requirements of this standard. Clause 7.8.2.1 Construction and demolition sites. Electrical installations on construction and demolition sites must comply with ASNZS 3012. Clause 7.8.2.2 Electromedical treatment areas. Electrical installations in electromedical treatment areas must comply with ASNZS 3003. Clause 7.8.2.3 Transportable structures and vehicles including their site supplies. Electrical installations in transportable structures and vehicles, including site supplies, must comply with ASNZS 3012. Clause 7.8.2.4 Marinas and recreational boats. Electrical installations in marinas and recreational boats must comply with ASNZS 3004. This standard has two parts, one for marinas and one for recreational boats. Clause 7.8.2.5 Shows and carnivals. Electrical installations in shows and carnivals must comply with ASNZS 3002. Clause 7.8.2.6 Cold cathode illumination systems. Cold cathode illumination systems must comply with ASNZS 3137. Clause 7.8.2.7 Telecommunications networks power supplies. Extra low voltage direct current power supplies within public telecommunications networks must comply with ASNZS 3015. Clause 7.8.2.8 Cranes and hoists. Electrical installations for cranes and hoists must comply with the relevant parts of the AS 1418 series or other requirements set by regulatory authorities. Clause 7.8.2.9 Lifts. Electrical installations of lifts must comply with the relevant parts of this standard. Additional requirements may apply depending on the type of lift installation. Clause 7.8.3, deemed to comply standards. Electrical installations in single domestic dwellings that comply with ASNZS 3018 are taken as meeting the requirements of this standard. Clause 7.8.4, specific electrical installation guidance. Clause 7.8.4.1, generating sets. Guidance on minimum safety requirements for generating sets operating at voltages normally not exceeding 50 volts AC or 120 volts DC is given in ASNZS 3010. Clause 7.8.4.2, outdoor sites under heavy conditions. Electrical installations at outdoor sites exposed to heavy conditions must meet the relevant requirements of this standard as far as they apply. Clause 7.8.4.3, electric fences. Guidance on the installation requirements of electric fences is given in ASNZS 3014 and ASNZS 3016. Where an electric fence is connected directly or indirectly to electricity supply mains, the connection must be through an improved fence controller. Clause 7.8.4.4, film, video and television sites. Guidance on safe procedures for electrical equipment and temporary electrical installations at film, video and television sites is given in ASNZS 4249. Further requirements may be set by regulatory authorities. That brings us to the end of Section 7. In this section we've covered a wide range of special installations, each with its own set of requirements to keep people and property safe. Whether it's emergency systems, generation systems, isolated supplies, extra low voltage work, high voltage installations or hazardous areas, the key idea is always the same: understand the risk, choose the right equipment and install it so it performs safely under all expected conditions. As you work with these types of installations, keep these principles in mind and always refer back to the detailed requirements when you need them. Now we can move on to the next part of the standard.